Okay guys, in this last video we're gonna learn how to deal with series parallel circuits. Okay, so far we've been working with a series circuit in which the elements are connected in series connection. We've been working with parallel connection, and now we're gonna mix them. We have this type of circuits in which we can find elements in parallel connected to other elements in series connection, like this first example up here, and another type in which we can find a series connection, like these two lamps in parallel with another element. So we're gonna learn just to solve the equivalent resistance, the total resistance. We are not going to calculate voltages or currents. This is something we will learn next year, but at least this year I want you to learn how to work out the equivalent resistance, how to reduce a circuit to a circuit with just one resistance. So we have two main types. The type number one is, I'm gonna call it just type 1, is a circuit with two resistance in parallel. You have them here surrounded by a red circle. These two, R2 and R3, are in parallel each other, and there is another resistance, number 1, which is in series compared with the other two. Okay, and we have a way to solve them, and it's just by solving first the parallel connection. So we start by getting rid of these two resistance, number 2 and number 3. So we have to apply the very well known parallel formula to find out the parallel resistance. Okay, so we work out these two, and then we get the parallel resistance. Once we have the parallel resistance, it's very easy because we only have to add this result to the first resistance, the number 1, which is in series. So the total resistance will be the result of adding the first one plus the parallel one we have calculated. Later we're gonna see an example. So the other type of circuit we can find is when we have, for example, two resistance, in this case R1 and R2, which are placed in series connection. They are in the same cable, and with another resistance in parallel. Okay, now the way to solve this kind of circuit is, now instead of solving the parallel because we cannot do it, first we have to get rid of the series connection. So we start by solving these two resistance, R1 and R2, and we know how to do it. Is just by adding the numbers. So R1 plus R2 is the equivalent series resistance. When we have this, we have to work out the parallel resistance with the other, with R3. Okay, so we take the first result by adding R1 plus R2, and this one is the one we're gonna use in this formula to calculate the parallel resistance. Remember that this formula is the one that you have to use that to get parallel equivalent resistance, but at the end you have to flip over to get the actual resistance. Okay, with this system you can solve many different circuits. You have 3 examples here. They are tricky one, but the point is that you have to look for parallel circuits, for example parallel resistance like these two. So in this case you would solve these two resistance in parallel, and then you would add the other two in series. In the second one we would start by solving these two in series, then in parallel with the other, and finally all this set of resistance in series with that one, and finally we have this one, this big circuit that you should solve it just by following step by step. These two in parallel, these two in parallel, and then this in series with this, with that. But we are not going to solve these difficult circuits this year. So we're gonna start with an example of type 1 in which we have this circuit up here with two resistance in parallel, 3 ohms and 6 ohms, and they are in series connection with another resistance which value is 4 ohms. So as I say, we start by solving the parallel connection. So we take these two values, 3 and 6. We already did this exercise, So we had to be careful just when adding fraction, because remember you had to have the same number down here to be able to add the numbers up here. So we add that, and then we get 3 divided by 6, that's 1/2. Remember that in parallel connection the formula gives you the reverse of the equivalent resistance. So after flipping this result over, we get that the parallel resistance of these two, the equivalent resistance of these two, is 2 ohms. Next step would be adding this equivalent resistance to the other we have in series. So this is a very easy step. The parallel equivalent resistance is 2 ohms. This resistance is 4 ohms. So we only had to add the two values to get the final total resistance, which is 6 ohms. So all these three resistance all together are the same as having just one resistance with a 6 ohms. Okay, so next example, we have the type number 2, in which we have two resistance in series, and these two are in parallel with the other. So first step is solving the series connection. It's very easy. We only had to add 4 plus 2 4 plus 2, and then we get 6 ohm. So these two resistance are equivalent to a single resistance with 6 ohms. And then once we have this, we have to solve the parallel connection. We have to solve this equivalent resistance that we already calculated was 6 ohm in parallel with this resistance number 3 down here. So we only have to replace the numbers. The series resistance, we know that is 6 ohm, the other is 3. So just by solving as usual, we get a final total resistance of 2 ohms. So all these three resistance are equivalent to a single resistance which value is 2 ohms. So with these two methods, you should be able to simplify or to solve any circuit just by solving type 1 or type 2 resistance. Okay, so I hope you know how to solve, how to face many different circuits. Goodbye.